Hi everyone, in this session we are going to learn about Thevenin's theorem. What Thevenin's theorem states is, in a linear network, containing multiple voltage and current sources and multiple resistances, the circuit across one set of open terminals can be replaced by a equivalent voltage source, which is known as Thevenin, and an equivalent resistance, which is can be represented by Thevenin. This Thevenin, this voltage across open circuit terminals is the voltage we are going to get across the open circuit terminals, and Thevenin is the equivalent resistance across the open circuit terminals when all the sources are replaced by their internal impedances. That means voltage sources are made as short circuit and current sources are made as open circuit. Suppose in this is a small circuit. In this circuit we want to find the current in 5 ohm. What we will try to do is, as we don't have any open terminals, we will try to create 2 open terminals, because our objective is to find a parameter in 5 ohms. Let us disconnect that from the circuit first. Then we got 2 open circuit terminals, 1 and 2, that we represented by A and B. In our case, what is Thevenin is nothing but VA, VAB, potential difference between A and B. It is nothing but potential at A minus potential at B. So if you closely observe, after removing these 5 ohms, these 4 ohms and 2 ohms have only one common junction, and at that junction no other element is connected. So these two are in series. Next, in this branch there is 3 ohms and 1 ohm. Both are connected by one junction and no other element is connected at that junction. These two are in series. So if you closely observe, this branch has 2 elements which are in series. This branch has 2 elements in series, and those 2 branches are connected in parallel. So same voltage 50 volts is applied across each branch. So if I apply voltage potential at A, it is nothing but, you can apply voltage division across these 2 points. I am interested in voltage at A is nothing but 50 volts into, this is the reference for us, so across 2 ohms by 4 plus 2, it is nothing but 100 by 6, it will be 16.6 volts. Next, similarly, if you apply for voltage across B, in this branch you have to apply voltage division. So voltage at B is nothing but, with respect to negative reference, it is voltage across 1 ohm. So it will be 50 into 1 by 3 plus 1. So it will be 50 by 4. It will be 12.5 volts. So VA is, we got 16.6 minus VB as 12.5. So it will be 4.1 volts. Our Thevenin voltage is 4.1 volts. Next, our interest is to find the Thevenin. Thevenin is nothing but the equivalent resistance across the open circuit terminals when all the sources are replaced by their internal impedances. That is, voltage sources are made as short circuit and current sources are made as open circuit. Let us represent this in this circuit. There are 2 open circuit terminals, A and B, and we won't disturb the resistances at all. And this voltage source we will replace as short circuit. So if you see here, this resistance and this resistance has 2 junctions as common. So these 2 are in parallel. Whereas this and this also has 2 junctions in common. So these 2 are in parallel. So if you represent, there are 4 ohm is in parallel with 2 ohm. Next, 3 ohm is in parallel with 1 ohm. So this one equivalent resistance is R1 R2 in parallel, R1 into R2 by R1 plus R2. So it will be 4 into 2 by 4 plus 2, 8 by 6. It will be 8 by 6, 1.25 ohms. There will be another resistance. It will equivalent is 3 into 1 by 3 plus 1. Its value will be 3 by 4. It will be 0.75. So these two are in series because they have only one common junction. At the junction no other element is connected. So the equivalent resistance is nothing but it will be 2 ohms. So R Thevenin we got it as 2 ohms. Next what we will do is we have created a set of open circuit terminals. Actually there is a 5 ohms across that open circuit terminals. That means for our convenience we have created a set of open circuit terminals. We find the Thevenin equivalent voltage as well as Thevenin equivalent resistance across the open circuit terminals. So what is our Thevenin voltage is 4.1 volts. Thevenin resistance is 2 ohms. So again if you apply resistance, these two are in series. So the current is nothing but, which is the current in 5 ohms as well as this 2 ohms, is nothing but voltage by, as these two are connected in series, the effective resistance is 5 plus 2. It will be approximately 0.6 amperes. Similarly, we can find any parameter, voltage, current or power in a particular element by making that as open circuit and finding the equivalent voltage and resistance across that open circuit terminals and representing them in Thevenin's as Thevenin's voltage and Thevenin's resistance, and substituting that element we can find any parameter, current, voltage or power. Thank you.